Tangents and normals to a parabola. Tangent. Let y squared equals to 4ax be an equation of a standard parabola. The equation of the tangent to this parabola at the point x1, y1 is given by y minus y1 is equals to dy dx of x minus x1, where dy dx is a gradient of the tangent. That is, y squared is equals to 4ax. It means 2y dy dx is equals to 4a. Differentiating this implicitly, that means dy dx is equals to 4a over 2y, which is the same like 2a over y. That is, dy dx is gotten in this formula by differentiating the equation of the parabola and making dy dx a subject of the formula. Let y squared is equals to 4ax be an equation of a standard parabola. The equation of the normal at the point x1, y1 is given by the formula y minus y1 is equals to minus 1 all over dy dx times x minus x1. That is, dy dx is equals to 2a all over y, as in the case of the tangent. But y here is y1. That means dy dx is the same like 2a all over y1. Example: find the equation of the tangent and the normal to the parabola y squared is equals to 2x at the point P with coordinates half and 1. Tangent. We know the equation of a tangent is given by the formula y minus y1 is equals to dy dx times x minus x1. So we need to look for dy dx. We get dy dx by differentiating the equation of the parabola implicitly. That means 2y dy dx is equals to, making dy dx the subject of the formula, I'm going to have 2 over 2y, which is equals to 1 over y. It means dy dx is equals to 1 over y. Here is the point y1, here is the point x1. That means y minus 1 is equals to 1 over y times x minus half. You know the equation of a tangent is the equation of a straight line, which can either be in the intercept form as y equals to mx plus c, or in the general form as ax plus by equals c. So let's simplify this equation in this form. That means y minus 1 is equals to 1 over 1 into x minus half. Dy dx is equals to 1 over y1, and y1 is 1. So it means dy dx is equals to 1 over 1, which is equals to 1. That's why I'm putting 1 over 1 here. That means y minus 1 is equals to x minus half, which means 2y minus 2x is equals to 2 minus 1, which is 1. So this is the equation of the tangent. Now let's find equation of normal. We know the formula to get the equation of normal is given by y minus y1 is equals to negative 1 over dy dx times x minus x1. So we need to look for minus 1 all over dy dx. But we know dy dx is equals to 1 and y1 is 1, x1 is half. It means the equation of normal will be y minus 1 is equals to minus 1 all over 1 into x minus half. You know the equation of the normal is also the equation of a straight line, which can either be in the intercept form or in the general form. So we need to rearrange this equation to be in the form ax plus by equals to c. That is, y minus 1 is equals to minus x plus half. That means y plus x is equals to 3 over 2. That means multiplying all through by 2, we are going to have 2y plus 2x is equals to 3. Gives the equation of the normal. Remark, let's say a parabola is defined parametrically as x equals to 80 squared and y equals to 280, where t is a constant, at a point P with coordinates 80 squared, 280. 80 squared is the value of x here, 280 is the value of y here. To find the gradient of this parabola at the point P, we need to evaluate dy dx. And to evaluate dy dx, we need to express dy dx in terms of the differentials of x and y with respect to t. That is, dy dx can be equals to dy dt times dt dx. You see here, I've not changed anything. If dt cancels dt, I am going to come back to dy dx. But dy t is equals to 2a. Dx dt is equals to 280. dt dx is equals to 1 all over dx dt, which is equals to 1 over 280. That means if I substitute these values here, I'm going to have 2a times 1 over 280. 2a cancel 2a, I'll have 1 over t. So this is a procedure to calculate the gradient when a parabola is defined parametrically.